space and the straight lines are not.
Bingo.
Yeah, that it must be something. And so, and then these are all physical representations that you've created
Yep.
that are all of those things.
Same things. That's the Aubryan right there.
How is this received? Like when you talk to people about this?
Oh, man, they first, because I hadn't shown them, I introduced it with, let's talk about our fundamentals are a little bit off. There are no straight lines.
Right.
So I reached out to Neil deGrasse Tyson. I saw him at an event up front, at Fox. And he was like, hey, man, yeah, I'd love for you to come on my show, do my radio, do my TV thing. I would love that. I was like, yeah, but I've got something I want to introduce to you. And it was only 36 pages. It was a treatise. And I told him it was controversial, and I sent him over the 36-page thing that had the wave conjugations in it, but I started it off with 1 × 1 = 2. And he went in on my treatise, redlined everything. He attacked that I had talked about Walter Russell and Victor Schauberger and John Keeley and Tesla as the people that I looked up to. Mm-hmm. He attacked them, but then he started attacking, the 1 × 1 = 2.
How did he attack them?
Oh, he was because I asked him. I said, under what conditions? I said, it's illogical where the square root of a number added to itself will equal more than that number squared. But that's what happens with the square root of 2. That's what happens with most of the numbers. I was like, how is it that multiplication, if it means to make more and increase a number, how is 1 × 1 = 1 part of the multiplication table? Now, I understand that if you're seeing it one time.
Right.
But we call that once. But the moment that you add the times in there, that multiplicative indicator, that means there's more than 1. So now each equation is supposed to be balanced. That equal sign is supposed to show that there's a balance between these 2 numbers over here and a balance on this one over here. What happened to the other one in this equation? It didn't equate. And then I took the square root of that number. I took the square root of 2, because all this started in 3rd grade. I was arguing with my teacher because we were talking about the square root of 100.
Favorite comedians, my favorite actors.
Yep.
Almost all of them are fucked up.
Yeah, my uncle used to call it, he said, if you don't get any flower to grow unless you throw some shit on it.
So back to Neil deGrasse Tyson and his critique of Tesla.
So he threw shit on, he was like, well, Tesla stuff worked, but Tesla was never really respected and out there. And I guess he wanted me to support Bohr or Schringer or Feynman or any of those people. And I'm looking at the Feynman diagrams. I'm like, you made all these things up. You're basically doing the Mr. Spock thing. If you want to find the answer to something, then you cancel out all the possibilities, all other possibilities, and you root it down to one thing. So that means going through the whole universe to answer one question. And that's the problem with probability. That's the problem with Heisenberg uncertainty. That's the problem with Schrodinger. All of those were just these probabilities because they had taken the ether out. They forgot the electromagnetic wave. Mm-hmm. It had to have a medium in which it followed on. It had to have something in which it was moving on.
They don't exist in isolation.
No, they do not. And it cannot be the cause of its own action. An effect can never be the cause of the action. The chicken cannot come the egg cannot come before the chicken. The chicken has to be there first in order to lay it. It has to mate. And what Einstein left out was the equal and opposite of magnetism. So back to Neil deGrasse, when he wrote his response to my paper, and he said, if you have any other questions, you're going to have to see somebody else, and he wouldn't take my calls anymore. I was like, okay, so I wrote the book based off of those responses, and I reached out to another guy, Dr. David Tong.
But that would be very, very interesting that would be his take as a public educator, that he wouldn't want to talk to you anymore.
The reason I wanted to talk to him was because of his show, The Cosmos, that he was doing after that incredible guy, Carl Sagan did. The very first episode he had was talking about Giordano Bruno. And he said that Giordano Bruno was looking for that grand unified field equation, and maybe one day somebody is going to do it. And when they do it, it's going to change the world. And I'm like, dude, I've done it. I've got it here. He attacked it with such vitriol that I was like, oh, okay, maybe I need to walk away from this. Dr. David Tong from Cambridge, a professor at Cambridge, did a video on physics of the world, and he said it's all a lie. And he explained that there was these 16 fields, that everything that they had taught was this, and they gave the best understanding and interpretation that they had of it. But it was all a lie because they didn't understand how it worked. Why? Because the Michelson-Morley experiment from 1887, where they were trying to define the ether or the earth in this etheric space. Problem was, they kept with Newtonian laws, so they thought the ether didn't move. They thought it was still. But there was another guy, Larmor, that did it in early 1800s, and he went off of Thomas Young, who influenced the Fresnel lens, influenced Fresnel, came up with the Fresnel lens. But he talked about a moving ether that had opposing vortices. So I didn't learn all of this stuff until I was getting ready to have conversations with people, because I was looking, where has this work been done? But if you look at Giordano Bruno's work, it looks a lot like my stuff, but he still had straight lines, and I think he put those straight lines in there to appease the church.
Oh, wow.
So that he wouldn't get killed.
Oh, my God.
And they still killed him. They hung him upside down in 1600, the Catholic Church. 1599, hung him upside down in a stake.
I do want to get to this, because I would love to know what you believe happened. But the Neil deGrasse Tyson thing is so confusing to me. That he was critical of Tesla?
He was critical of Tesla, he was critical of Walter Russell, and he was critical of John Keeley.
This is not his field of study, though, right?
No, he's an astrophysicist, but Walter Russell talked about that Walter Russell talked about the fact that the sun gave birth to the earth, that it didn't coalesce from some field, and the proof of this. Do you guys know that the earth is drifting away from the sun?
Yeah, slightly.
This is the mistake I made at the Oxford, because they wouldn't allow me to bring my notes or anything. So I said the drift was 6 inches a year. It's 0.6 inches a year.
I recently learned I got name-checked by Terrence Howard on his recent appearance on Joe Rogan.
I reached out to Neil deGrasse Tyson. He was like, hey, man, yeah, I'd love for you to come on my show, do my radio, do my TV thing. Would love that. I was like, yeah, but I've got something I want to introduce to you.
I got name-checked because 8 years ago, he sent me a 36-page treatise.
And it was only 36 pages.
So this is Terrence Howard attempting to reinvent mathematics and physics. A little backstory there. I took initial interest in Terrence because my mother said to me, do you know Terrence Howard? I said, yeah, I know. You mean the actor? She said, yeah. Well, I heard him interviewed on NPR. On there, he said that like when he was a kid, he wanted to be like a scientist and study the universe. I said, well, that's cool. Okay, maybe we'll get him on Star Talk. We love talking to celebrities who have a sort of soft geek underbelly. At the time, I didn't quite know how to get in touch with him, but we met at something called the Upfronts, which is where networks present their next season's TV shows.
I saw him at an event Upfront.
And then this came in my inbox. In this particular case, since I basically solicited it from him, I actually spent time reading every line of all 36 pages. And I commented. My comments are in red here. You see that? So I spent a lot of time on it. And I thought, out of respect for him, what I should do is give him my most informed critical analysis that I can. In my field, we call that a peer review. You come up with an idea, You present it either at a conference or you first write it up and you send it to your colleagues. It is their duty to alert you of things about your ideas that are either misguided or wrong, or there's the calculation that doesn't work out, or the logic doesn't comport. That's their job. Not all ideas will turn out to be correct. Most won't be. But to get to that point, you need to know things like, what has everyone else said about this same subject? Am I repeating someone else's work? Is this a new insight that no one else has had, but has foundations that are authentic or legitimate or objectively true? Am I making a false assumption? Am I making an assumption that someone else has already shown to be false? All of this goes on the frontier of science. Let me make it clear that I'm delighted when I see people with active minds trying to tackle the great unknowns in the universe. It's a beautiful thing that people want to participate on this frontier. What can happen is, if you're a fan of a subject, let's say, a hobbyist, let's call it, it's possible to know enough about that subject to think you're right, but not enough about that subject to know that you're wrong. And so there's this sort of valley in there, a valley of false confidence. This has been studied by others, and it's called the Dunning-Kruger effect. It's the phenomenon where a little bit of knowledge, you over-assess how much of that subject you actually know. And then when you learn even more, you realize, no, I didn't know as much as I thought I did. So then there's a sort of a lull there. And then when you learn even more, you come back up. Ultimately, learning enough to know whether you were right or wrong. To become an expert means you spend all this time. It doesn't happen overnight. You can't just sit in an armchair and say, I'm now an expert. It requires years and years of study, especially looking through journals where new ideas are published and contested. That's what we have learned is the most effective means of establishing that which is objectively true, or determining that which is objectively false. Both of those work hand in hand to move the needle on our understanding of the universe. I'm going to read you just my opening line here. It's titled 1 × 1 = 2. So I lead off by saying, this is an ambitious work that is a clear indication of a restless, active mind. Within these pages, however, there are many assumptions and statements that are underinformed, misinformed, or simply false, thereby compromising or nullifying many of the subsequent conclusions you have drawn. That's exactly what should happen in a peer review, out of respect for one another's intellect. It opens with a quote from Terrence. It can never occur that the square root of a given number, when added to itself, is greater than the initial number squared, for that would expose a loose thread within the fabric of our understanding, a loose thread capable of unraveling the very ground rules of mathematics. That's a bold statement. So then I just say, this opening thesis is false. There are plenty of examples of this that have escaped your attention. His statement is shown to be false for every number that's less than 1 and greater than 0. For example, the square root of 0.64 is 0.8. 0.8 is bigger than 0.64, and it's a larger number than the original. And 0.64 squared equals 0.4096, a smaller number than the original. To the extent that the next 35 pages depends on your stated thesis, this fact undermines your claims and assumptions and conclusions. It's not about feelings here. It's about objective reality. So at the time, I considered Terrence a strong acquaintance, and we hung out a bit and had much exchange. We haven't spoken much since then. But go to page 2, and in here, he mentions people who he declares were persecuted because their vision exceeded the myopic view of their contemporaries. And he mentions Walter Russell, Nikola Tesla, John Keeley, and many, many more. Regarding your list of people who have made brave sacrifices, I note that to be a genius is to be misunderstood, but to be misunderstood is not to be a genius. The work of Russell, Walter Russell, has eluded any experimental support, and the work of Keeley is generally not reproducible. Science is about reproducibility. I can have the most brilliant, crazy, fun idea ever. And if I perform an experiment and no one else can duplicate that experiment, it belongs in the trash heap. It's me in my own world, thinking I have landed on an objective truth, when in fact I haven't. That's how science works, the reproducibility of results. As for the work of Tesla, much of it had very real value to physics and our understanding of electromagnetism. And that value is duly recognized by my community in the naming of a unit of electromagnetism after him. You can't get more badass than having a unit named after you. Newton has a unit named after him. For example, the metric unit of force is a Newton. Much of the rest of his work was fringe and unrealized, either for violating known laws of physics or for being simply impractical. Just because you do some good stuff doesn't mean everything you ever did is going to be great. I will further affirm that just because an idea sounds crazy doesn't make it wrong. The system of research and publications in peer-reviewed journals has the capacity to spot crazy but true ideas, provided they're supporting by compelling arguments, and ultimately supported by experiments and observations. Newton's laws, Einstein's relativity, quantum physics were all revolutionary ideas that appeared in peer-review settings or journals. Meanwhile, most of the work of Russell and Keeley had no such success with their ideas. So I think on Rogan, Terrence said that I trashed those three researchers.
Attack that I had talked about Walter Russell and Victor Schauberger and John Keeley and Tesla as the people that I looked up to. So he
Tesla.
threw shit on he was like, well, Tesla stuff worked, but Tesla was never really respected and out there.
When I'm just simply stating the fact, I don't think of that as trashing. I think of that as being honest. I mean, I could have softened it, but I don't think that's what people who care about you should do. People who care will be honest with you about ideas, about thoughts. The world is changing so quickly, and so is everything around us. Unfortunately, we have chosen to remain handcuffed to antiquated and obsolete beliefs. We have put an enormous amount of faith into the methods and practices of old that are as dead today as the men who propagated the notion that the world was flat. So I say here, regarding your world was flat reference, it's not widely appreciated that the idea of a flat Earth predates the introduction and development of the methods and tools of science as we practice them today. Those processes date back to around 1600, coincident with the invention of the microscope and telescope. Before then, truths were whatever seemed right to the senses. Afterwards, and to this day, truth was whatever the verified data obtained by your instruments forced you to believe if your senses otherwise contradicted the data. This fact means that there's no such misunderstanding on the scale of the flat Earth in the era of modern science. And in multiple places throughout the treatise, he's attaching a number to a physical idea or a physical object. That idea goes way back, by the way. Go back to Pythagoras, famous for the Pythagorean theorem, which we all learned in 8th grade, was it, or 9th grade? Pythagoras was also a philosopher who tried to understand how things worked. He felt, among others in his group, that if you assign a number to something, the number can imbue that object with certain meaning and significance, which means then if you manipulate the numbers, that you gain insight into the objects themselves once you've assigned a number to it. There's a lot of that permeates this document, but it's a long disproven approach to the world. Again, there's nothing wrong with a failed idea. Now other people know to not do it, right? That has value. If we place a candle in front of a mirror, the measurement of light is doubled, is it not? It does not measure as only one light source. We actually see two lights. A light meter will show twice the intensity of light. This is false.
He attacked it so with such vitriol.
Maybe that's too blunt. What else should I say? I'm a scientist. That's what I would tell a colleague who then say, "Would thank you," and then we go out for a beer after, because that's how that works. And there's an old saying, I first heard it from Michael Dell of Dell Technologies. If one day you find yourself the smartest person in the room, change rooms. I say this is false. The light in the mirror appears dimmer than the source of light itself, for several reasons, starting with the fact that no mirror is 100% reflective. But more importantly, the candle in the mirror is always farther away from you than the candle itself. So the light meter will always read less than twice the actual value of the candle itself. I will note that from this work, Terrence produces art, sculptural art, which I find to be intriguing, even beautiful. To me, more intriguing than beautiful, because you got to look at it and you keep looking at it, like, what is that? And what's going on there? I just want to read you my ending comments here. I could not follow the reasoning on these last few pages, but the illustrations that derive from them are beautiful, regardless of how they were derived. My notes have been strongly critical of your reasoning and conclusions. I was candid and blunt out of respect for the energy you have clearly invested in this work. But if you're sure that you are still right and that I have completely misunderstood your thesis, then you will need to look for another person to evaluate what you have done and solicit their comments. In any case, like I say above, the images and illustrations in your final pages are beautiful works of art, unlike any I have seen. Best to you, Neil. So, in case people wanted to know what actually went down 8 years ago, just always be cautious of the Dunning-Kruger effect. You put in a little bit of work and you have an idea, and then you think your idea is right and that Einstein is wrong and Newton is wrong and that everybody's wrong and that all of modern astrophysicists are wrong. That's bold. That's bold. Audacious. Bodacious. When continental drift was proposed, it was like, what? Land masses are moving on Earth's surface? That's a weird idea. That's going to be a hard sell. We think there's sort of upswelling of the, yes, locally, but whole continents, that's crazy. It would take a few decades until ultimately, when we're mapping the bottom of the ocean, we find that there's a mid-Atlantic ridge that the ridges are separating. It's like bada bing. So the resistance to jumping on the idea that continents move was not because people were stubborn. It was because people are cautious. Any new idea needs to be put through the ringer. That's how science works. You put it through the ringer. Every possible test you can. Not just because it happens to look like South America fits with Africa. Any better evidence than that? Oh, wait a minute. Fossils matched between the west coast of South America and the east coast of Africa. Not recent fossils, fossils from millions of years ago. That's interesting. Things that make you go, that brought some more people over to the camp. You keep that up and you reach a point where enough evidence is brought to bear on the question, and then you have a new emergent truth. But at the vibrant energy that goes on at conferences and the contest of ideas, that's how we roll. That's how it works. When Einstein came out with relativity, saying space-time curves, Al, what are you saying? What are you doing? Well, you can test it with a total solar eclipse. So the idea comes out in 1915, is published in 1916, 1919. We measured light around the edge of during a total solar eclipse, because you can't see the stars during the daytime. You see the light rays bent from their actual coordinate positions on the sky. Sir Arthur Eddington, an astrophysicist, provided the first experimental evidence for Einstein's general theory of relativity, which, by the way, was published in a peer-reviewed journal. Crazy idea. The platform to be accepted for the ideas is not social media. It is not Joe Rogan. It is not my podcast. It is research journals where attention can be given on a level that at the end of the day offers no higher respect for your energy and intellect than by declaring that what's in it is either right or wrong or worthy of publication or not. I wanted to post this to my website so you can see my comments mixed in with his treatise, but you got a sense of it. Thanks for listening. Thanks for watching. Neil deGrasse Tyson here. As always, keep looking up.